All right, is everybody able to settle for the 1.1, 1.2, and also 1.3? Is it already done? So in this case, let us have a look. So you just compare back what have you done to my configuration on the switches and also on the routers for the VRP protocols. So is everybody get ready? So first I define on the switch number one first. Okay, switch number one. So it said that on the switch number 1 and 2 on the port 02 as an access interface, PVID is 10. Okay. And switch 3 port 1 is also PVID 10. So for us to doing this, first on the switch 1, make sure that when you display VLAN, so there no VLAN 10 has been defined yet. So for this exam, it's not like the old one, the version 2, because on the version 3, the exam, some of the configuration they already predefined for you. Like when you check on the CE, like you can see that the addresses had already configured. The IP address has been configured, predefined already. So actually, it's not just everything start from the beginning. All right. So in this case, for the first question over here is on the switch 1, I was just creating the VLAN 10. Okay. And on the port of the port 2, interface gate 002, and I said that it's a port link type access. Port default VLAN 10. So that is how we assigning the interface. Okay, based on the requirement here. Okay, port 2. Same as the switch 2. We do it requirement by requirement. VLAN 10, interface gate 002, port link type access, port default VLAN 10. Okay, same to the switch 3, port 1. VLAN 10, interface gate 001, okay, so that is the basic, the first question they mentioned over here. That's how we define allow VLAN to pass through. The second question. Let us check configure it first. Okay, the access interface has been done as a PVID 10. And the link type of the interface between the switches is trunk, and also you need to allow a VLAN 10 to pass through. Okay, allow VLAN 10 to pass through. So in this case, we have to check either you check you can go up all the way and check which interface they're using. Port 12, port 10, and port 24. Okay, 12, 10, and 24. These are the three interfaces that are interconnected between the switches. And this between this device interface, you need to define as a trunk connection. Okay, define as a trunk connection. So this way I'm going to perform. I first configure on the switch 1. Switch 1, they have a port 10 and port 24. All right, so that is where I should define here. Switch 1, go to the interface, gate 0010, port link type, trunk, port trunk, allow pass VLAN 10. interface gate 0024, port link type, trunk. Port trunk allowed pass, VLAN 10. So that is on the 2 port I need to define on the switch number 1. Is that okay so far? So far okay? So that is on the switch number 1. Next, switch number 2. Switch number 2 is a port 12 and port 24. So you need to do it slowly. Make sure that the information that you did from here do it correctly. Okay. No worry, because you should have more than enough time to complete entire lab within the 8 hours. So now I'm going to do it on the switch number 2. It's a port 12 and port 24. So I need to make sure that interface is correct. Okay. Port 12, port link type, trunk. Port trunk, allow pass, VLAN 10. Interface gate 0024, port link type, trunk. Port trunk, allow pass, VLAN 10. Okay, that is what you should define from here. Okay, for interface port 12 and port 24 on the switch 2. So far, okay? Switch 3 and switch 1. What you mean by the notepad file for switch 1 and switch 3? Is it this one? You want me to share into the group or show you from the slide?
Okay, you can share on the group, please. Thank you.
Hold on. Or maybe let me finish everything first, because I try not to. This is on the 1.1.
Okay, go ahead.
Okay, switch 3 in this case is a port 10 and port 12. Okay, port 10 and port 12.
Tar. Bentar.
Okay,
WA.
interface. Zainji, can you please mute yourself? Thank you.
Kita ketemu dokter begini bunyi.
Zigit, is it Zigit? Can you mute yourself, please? Okay, so that is on the switch 3. There's a port 10 and also a port 12. Okay, port 10 and port 12. So I copy this into the notepad. All right, this is on the switch 1, switch 2, and the switch 3 configuration, access interface, and also on the trunk interface. So you can see that it's not too difficult to complete this. So as long as you just follow a step by step, that it should be fine. So, and then next, let's have a look on the next question here. So the next question over here is talking about on the MSTP. So under MSTP, all the switch 1, 2, 3 running MSTP, VLAN 10 as an instance 10. So they only define a single instance from here. Okay, only one instances only. So when one instances, it will be easier. In this case, we just have to have instance 10, VLAN 10. But definitely in your exam, they should not be that easy, that simple. They should going through more detail. So it means that in the exam, they're going to have multiple VLAN and multiple instance. Okay, so you need to be aware on this. And in the exam, they will not only ask you 3 devices, they must ask you more than 3 switches. Maybe there are 4 switches in total in a square connections. Then in this case, that is where you're going to provide the loop prevention. But in this case, they will need show this. Okay, I will do the 1.2 right now. All right, 1.2. 1.2. So for this 1.2, switch 1, 2, 3 running MSTP, VLAN 10 is instant 10. Switch 1 root primary, switch 2 root secondary. MSTP region name is called Huawei and revision level is 12. So all this you need to make sure that it's been done to every single switches. So I do it on the switch number 1 first. Okay, I do it on the switch number 1. So for us to define the region information, so how we define the region information? Do all of you still know how to define the region information? So first we need to go to the STP regions. Okay. STP regions configuration. Define the region name called Huawei. Oops. Huawei. Okay, it's all capital letters. It's all capital letters. And revision levels 12. Instant 10. VLAN 10. And the more important is this active region configurations. So that is all the most important. That is what we need to define. Active region configuration. So after that, you can always just display this and copy this information. You do not need to type. Make sure that you do not have any mistake on typing to create the wrong region name or define the wrong revision numbers. So it's better you just copy the configuration and paste it here. And paste it here. Okay. To make sure that they have no same mistake that you're forming the same things. Okay. Make sure they will not get back the same mistake from here. So this is how I defining. It's okay. So how we're going to set on the spanning tree on the MSTP. Always just copy and paste. So from here, let me just copy this into the notepad for 1.2. All right. So there will be switch 1, 2, 3. It should having the same and identical configuration on the basic MSTP configuration. Okay. That should have this information. But not only this, it's not ended yet. This one is just to define the MSTP for all the interface. But inside, they're still not specifying. It's still not fully specifying that who is the root bridge and who is the second root bridge. So that is need to be defined. So how we're going to define from here? I'm going to set from here. So they said that switch 1 is belong to the root bridge. Okay. Switch 1 belong to the root bridge. So from switch 1, I'm going to quit and set that STP instant 10 root primary. You can use it root primary or you can using the 10 priority 0. So you have two options to achieve this. But when the question said that it just set as a primary, you just make it as the root primary. It'll be easier because you're getting the same result actually. Okay, switch 1 is a root primary and switch 2 as a root secondary. Instant 10 root secondary. Okay, that is how we define from here. Okay, based on the question said that switch 1 root primary, switch 2 secondary root. Right, this is how I define here. So let me just copy this. Okay, root primary and root secondary. So that is what we need to do on the 1.2.1. 1.2.1. The 1.2.1, that is what we required to perform. It's pretty straightforward. That is where we're defining from here. Is that okay? Any questions so far? Okay. So after that, after the switch 3 gig port 1, switch 1, switch 2, port 2, interface turn up, they must enter into forwarding state immediate. After the interface receive PPDU, the interface is automatically shut down. So what are the main functions they ask us to perform here? So actually, this over here, they ask us to define the H port, the port fast. When you know that inside the ISTP protocols, the port fast is that when this connecting to the host, I do not require any calculation. They do not need to doing the proposal agreement, immediately become forwarding. So to skip all the step of learning and also listening before it go for the forwarding. That is called as a port fast. But in Huawei, this is called as a H port. Okay, H port. So what I should do from here, just now is that from switch 1 and switch 2 for gig 002 and switch 3 gig 001. The interface connecting to the routers and the PC need to change to immediate as a forwarding interface. So from here, I go to the switch number 1 first, interface gig 002, and set that STP H port enables. This is how you're going to enable the H port. All right, same case to the switch 2, interface gate 002, STP H port enables. Sorry, this is without the dash. All right, and switch 3, interface gate 001. STP H port enables. Simple. But it's not finished yet. It said that after the interface receive BBDU, so let's say the BBDU it be sent and received from that interface that enable BBDU, enable the H port, the interface is automatically shut down. So it means that you need to do some protection. By right, a normal H port, they will not shut down. By right. Okay, they will not shut down. Only when you set the protection, we call as a BBDU protection on the switches, then only they will shut down if let's say they receive a BBDU. Okay, so on switch 1, 2, 3, I need to do this. STP BPDU protection. Do it globally. This global command will be applied to whichever interface enable H port, it be protected by the STP BPDU. Okay, they will have protection. Enables automatically under the interface with the H port configured. So same thing, STP BPDU protection. STP protection. Okay, that is what we are doing over here for this question. So you have to check the question carefully. So what the question is being asked, you need to know very well. So what is they up to from switch 1, switch 2, and switch 3. Check carefully what it should be done. So I copy this. Yes, any questions? Michelle, can you mute yourself, please? Okay, so that is on the question that we asked on the 2.1 and 2.2. Okay, that has been completed. So that is a step. So MSTP configuration, root bridge selection, and also export with the BBDU protection. So they over here, they might ask one more question here. They said that if let's say they want to perform the auto recovery, if let's say detected from the BBDU protection, let's say detected BBDU shut down, I need to have a mechanism to restore back the interface. So what we should do over there one more command it will say that is a error down, auto recovery caused by BBDU protection, interval for how many seconds? Default 30 seconds. So this command, it means that if let's say the interface down is because of BBDU protection, I will try to recover after 30 seconds and test. Is it still get protected or not? You still receive BBDU or not? Let's say I receive BBDU, I shut down again. So this can be auto bring up the interface. When detect BBDU, shut down again. And bring up again after the interval and shut down again. So that is just to help you to doing auto recovery. So you do not need to ask the administrator do it manually. So this can be done using the auto recovery. This is one of the way. Let's say the question asks you. They could ask you this method as well when the interface down because of BBDU protection, how we perform the auto recovery. That is a command. Okay, this is just from extra things I'm going to highlight it to you. Let's say the question asked this way. This is how you should answer. All right. And next, that is okay. 1.2. Finish on the 1.2 already. So the next one is on the 1.3. Okay. 1.3 VRP run between CE1 and CE2, and the virtual IP address is 10.3.1.254, which is the gateway of the PC. And the priority of the CE VRP is 120, configured oh, layer 3 BBFD. Let me do it the 1.3.1 first. Just set the virtual routers VRID first. All right, someone asking question. By default, there are no auto recovery. But let's say the question asks for auto recovery, then you need to do that. By default, they have no auto recovery. By default, when that go down, it's go down. Okay?
How long time?
They will just permanently down until you do it manually bring up and do shut yourself.
Oh, okay. Okay.
Yeah, there's a default. Default, they have not provide auto recovery. Okay? So, and now we are doing on the VRP. This VRP run between CE1 and CE2. Okay? So we have a router called CE1 and CE2. Define this virtual router's IP address is 10.3.1.254. And the gateway is CE1 to 120. So what you're going to do from here is we can go to the CE1 and CE2 and perform the configuration here. Okay, I go to the CE1 first. Okay, so address has been defined. This is the interface that I need to define the virtual interface. Okay, VRP interface under the gate 002. But before that, let me check display current over here. Okay, there's only interface configured. All right, that's good. So how we configure a VRP? We need to go to the interface first. Interface gate 002. Okay, gate 002. Then followed by the VRRP VRID 1 virtual IP address as 10.3.1.254. Okay, followed by VRP VRID 1 priorities 120. Because it said that CE1 be the master. Default priority in the VRP is 100. Okay, so I want to increase myself as 120 become the master. Okay, that is what the requirement mentioned. Okay, the priority of the CE1 is a VRP is 120. So it means that CE1 as a master. And CE2, it should be under the same interface. Let's check the interface. 10.3.1.2 is correct. So I will do this. Interface gate 002, VRRP VRID 1, virtual IP 10.3.1.254. That's all. You do not need to define the priorities over here. Let's double check. How we know that, how we check that right now the VRP is running fine. You can do this command, display interface, VRRP interface gate 002. So you found that right now the status here is a backup. Who is your master? Master is 10.3.1.1, CE1. And the master priorities is 120. And config run under my device is 100. There's a default value. Okay? So this is to show that, oh, your VRP is working fine already. That's how they prove from here. Okay? Under interface VRP, that is on virtual IP 10.3.1.254. You also can check on CE1, display VRP interface gate 002. Okay, that is master IP, virtual IP. Okay, that is all the detail I should receive from the VRP configuration. Okay, let me copy this into the notepad. Okay, next, this is on the 1.3. Yeah, 1.3. VRP C2. All right, that is on the first question that I need to define. So it's simple. Next, configure a layer 3 static BFD on the CE1 gate 001 and PE1 gate 001. So you need to define a static BFD. How we define the static BFD here is, so you need to build your BFD manually yourself from CE1 to PE1, and CE1 VRP, we're going to track this BFD. Let's say this BFD go down, CE2, you become the VRP masters. Let's us check from back to the topology here. Okay, let me zoom in from here. So that's where they concentrate over here. From CE1, I need to build the BFD, go to the PE1 on this interface. Okay, PE1 on this interface. So it means that I'm going to do the static BFD, static BFD. So I need to build the BFD first, then only I can peer doing the CE1 to PE1. So let's look into how I configured for this. All right, let's follow. So on the CE1, I go back to CE1. First, configure BFD first. For us to define BFD, have to BFD enables. Okay, BFD enables. BFD, I define this as a VRP BFD, bind for the peers IP. My peer IP is, let's say, refer back to this, is a 10.2.11/30. CE1.1, PE1.2. So I make it as a 10.2.11.2. Okay, followed by the interface gate 001. This is the interface that I going out. Okay, and I said that this is on the discriminators. Locals is 1. Discriminators remote is 2. Commit. So that is what we need to be done on one side. For BFD, must be bidirectional. Must be bidirectional between the CE1 and also between the PE, between the PE1. Okay, so I go to the PE1. So I check on display current first. You see what information that has been done from here. Okay, so far nothing. All right, that's good. So I define a BFD. BFD, VRRP, binding, peers, IP, 10.2.11.1, interface, gate 001. So this gate 001, okay, communicate between the devices. Okay, then from here, discriminators, locals 2, remote 1. So this is a match between the CE1 and PE1. So when CE1 I'm locals 1, then PE1 remote is 1. Local is 2, then remote is 2. So they need to be matched. So that is how they perform the bidirectional BFD section. To check the status over here, you can always just display BFD sections or. So it's up right now. Okay, it's up and running right now. So there's one more step that need to be done. They need to be binding this BFD into the VRRP on the interface CE1 gig 002. All right, I need to track this interface. If let's say this interface anything goes wrong, I need to reduce the priority myself and shift to the CE. Why? Let me just explain to you first. VRP running over here right now. I will see whether I can draw anything or not. Okay, never mind. So between the CE1, CE2, they're running the VRP. When VRP running, they only can detect gig 002 is, let's say, any failures. Then I will just shift over to the CE2. But when the uplink go down, they cannot trigger the VRP. Let's say the uplink G001 go down, what will happen? When G001 go down, the traffic, you will go to the CE1 first and come back to the CE2 and go out. Because of my interface uplink go down, it's not trigger my VRP. So by this, how we're going to perform here is I need to go to the interface gate 002 and set that VRP VRID1 track BFD sessions. So what is my session IDs over here? Let me just double check from this. Display BFD sessions. So that's ID number 1. All right. Okay, these are on the session IDs. Interface gate 002 VRP VRID 1 track BFD sections. So local session is 1 and followed by either you increase the priorities or you reduce the priorities. What should we do over here? So when the uplink go down, I have 120. My P is 100. So I should be reduced more than 20 and above to make sure that I'm less preferred. So to let the CE2 become a preferred, I can set as a 25. Reduce 25. Subconfig BFD. What I mean by subconfig BFD? What do you mean by the subconfig BFD? Hold on, let me just finish this first. I will handling your case. Okay. Okay. You check carefully the command, is it correct or not? You just go to BFD first. BFD, the name. You need to assign the name first before bind. It's not bind before the name. Okay. You try this. I will copy this command into the WhatsApp. So you try this, copy into the configuration. Try whether is it work or not. Okay, so I copy this information into the notepad first. It's on the CE1s and PE1. And CE1, they have this added in. Is it okay after you copy the command that I shared just now? Is it workable? Okay, that's good. So remember, sir, for the CE1 and PE1 are different, sir. So the address will be different. The IP will be reverse, sir. IP reverse. So make sure that you have follow on this. So you double check whether your BFT section is it viewed properly. So make sure you do it on the correct interface, because this might be two direction. It's not only one direction. Right? After you're done on the CE1, you still need to go to the PE1 to do the same step, to match the same information. Let's say this information is not matched, they will not able to form. All right. So I will copy this. Never mind. Right now, I will just share you the notepad. Okay, share you the notepad. So you try to check whether the configuration that you did and compared to my text file, is it identical or not? Okay. Okay. You recheck again. Let's say you still have issue, then you let me know. I'm going to solve it for you. All right. And over here for the next portion here, we are going to configure on the IGP. Okay. IGP. So around right now is about 10:30. So let us take a break first. Take a break of 15 minutes and come back. We continue with this OSPF and also ISIS. All right. Let's say you want to start now, you can start the OSPF as well. You can also start ISIS as well. Okay. So it depends. Let's say you want to just take this time opportunity, you can just starting, or you can take a rest first. Later, after come back from the rest, then you only start on this. I'm going to explain one more time to give you the guideline what we're going to perform on this number 2 portion, IGP portion. Okay. So let us take a break. Okay. Take a break of 15 minutes. So from 30 to 45. All right, I will back on 45. Let's say any question, you just ask me again. All right, thank you. So let me just double check. Just on the port 2. Actually, it's completed already. The gig 002 from CE1 and CE2. CE2 just as a backup. So nothing much you need to define. You just need to do the normal VRP configuration only. Okay. So this one, that's correct. That is already completed. All right. So from this, it's only do it on the master. And this is a BFD between the PE1. So the CE2 actually has a complete configuration already. Okay. It's a complete configuration.
When the interface at the CE1 GE002 is down, is there not impacted to the hierarchy process or
So when the interface gate 002 go down, CE2 will take over.
automatically?
Yes,
Oh,
automatically. Because we already defined, just now I show you already, right? On the CE1, when you check this status, display VRP interface gate 002. So they tell this is a master right now. CE1 is a master. CE2 is a backup. Okay. Let's say right now, you can just simply just do a testing. Go to the interface gate 002, shut down. Okay. CE2, you be the master. Okay. Master. See that? It's automatically.
okay. By default is 100 for
By default is
priority.
100. Yeah, correct.
Oh,
By
okay.
default is 100.
Okay, thank you.
Okay. So for this, on the section number 1, layer 2, is it everything is okay? All right. So can I proceed to the section number 2, IPv4 IGP? Okay, let's is okay from here. Then I'm going to go through this. So for the IPv4 IGP, configure IPv4 address of interface on all devices as shown into the figure 1. That is already pre-configured already. It's already done. The router ID is same as the value as the IPv4 address loopback 0. And this is not done yet. So you need to configure router ID manually when you configure the protocols. Okay, so that is number 2. Number 2 is that has not been done yet. So it means that we need to go to every single interface to define the loopback as a router ID. Loopback as a router IDs from interface CE1 all the way up to the PE4 over here. Even though up to the CE3, need to configure a loopback interface. Okay. Then next is on the 2.2 OSPF. In the AS200, loopback 0 and interconnected interface are all advertised into OSPF area, and the cost value of each link is configured as shown into the figure number 2. So that is a figure that you need to define the cost in between. This on the OSPF. Yeah, this on the OSPF. All right. So that is where we need to define right now. Okay, where we're going to define right now from ASBR 34, RR3, RR4, PE3, PE4. Okay, that is a device that we're defining. And also we need to set the cost for the OSPF cost that which interface they are facing to. So you need to set the cost, see to advertise the OSPF. Okay. So that is where we're going to define from this. Is it all right so far? Okay, so that is a two interface. So for, let's say for ASBR example, ASBR in total have three interface. One loopback, gate 001, gate 00. ASBR4, gate 00, gate 001, and loopback interface. RR3 have four interface, three physical and one logical. RR4 as well, three physical, one logical. Need to be advertised into the OSPF. So this tooling is not advertising. The tooling is not. Let me just double check for this. 10168. Yeah. This tooling is not being advertised yet. Okay, it's not being advertised. It's only advertised within your areas. Okay, only advertised within your areas. Between the ASBR34, RR34, and also PE34. This is the 6 routers inside the OSPF. Make sure that the costs are correct, that assigned accordingly. 100, 1000, 50, 1500, 1500, and also 20. So make sure the cost you define properly over here. Is that right? So from here, I'm going to leave it to you to perform this. Then I'm going to show you that how we define on the OSPF. So the first, let's do on the OSPF first. Okay, on the 2.2.1, let do it this option, then only go to the ISIS. Okay. Let's do 2.2 first. So I'll give you about 15 minutes to configure the OSPF. Yeah, to configure OSPF. Make sure you need to know what to define here. Okay, so that is on the OSPF from 10:55 to 11:10. Yeah, that is the, I want you to complete all the OSPF configuration between the 6 routers. The 6 routers. 15 minutes should be more than enough. Yeah, after that, you're going to check with the answer. I will show you the answer from here. All right. All right, so already settled on the OSPF configuration. Yeah. So in OSPF, 6 routers need to configure the OSPF. Okay, based on what information they provided. So instead of looking into this, loopback 0 also need to be advertised and interconnected need to be advertised. So from here, I will just show the diagram to perform the configuration. Okay, using this to configure is better than just using the word over there. So based on this information, I can perform this configuration already. Okay. So from the start from ASPR3, okay, ASPR3 4, RR3 R4, and PE3 PE4. Okay, and over here you need to know what's the interface, display IP interface. So that is on the 78, 79, 89. Okay, 89. And loop back 170.16, 1.7. Okay, ready? So I'm going to do it on the ASPR3 first. Okay, that's how I'm going to configure it now on the ASPR3. Okay, so always first thing doing the router ID. So the router ID is 172.16.1.7. Okay, OSPF, area 0, network 10.1.78.1. Network 10.1.79.1. Network 172.16.1.7. All right, this is the 3 network into the ASPR3. Is that okay? And after that, we need to define on the interface. Like interface gate 000 and gate 001. Set the cost of 100, set the cost of 1000. So I go to the interface, gate 000, and set that OSPF cost 100. Okay, gate 00, and interface gate 001, OSPF cost 1000. Okay, that is the configuration I need to done on the AR3, the ASPR3. Is that right? Okay, I will copy this into the notepad. Okay, this is on the ASPR3. So did you do the correct way? Okay, so after that, I will just minimize this and configure ASPR4. Okay, ASPR4 also have 2 physical interface and 1 loopback interface. So for me to easier to define, I displayed IP interface brief. So to know which interface to which interface. 00 and 001 means that 78 and 81. And this is my loopback. So first, router ID 172.16.1.8. Okay, this is my loopback interface, my router ID. And next step, I go to OSPF area 0, network 10.178.2, network 10.181.1, network 172.16.1.8, interface gate 00, OSPF cost 100, interface gate 001, OSPF cost 1000. Okay, that need to be done on the ASPR 4. Is that right? Okay, so I copy this into the notepad. So followed by the RR3. So RR3, they have more configuration on RR3 because I have 3 physical and 1 loopback interface for RR3. I need to change the 3 interface costs 1050, 1500. All right. So on RR3. So display IP interface brief. So I need to check this interface they're using right now. So I have a routers ID 172.16.1.9. Okay. OSPF 1, area 0, network 10.1.91.1, network 10.1.79.2, and network 10.1.119.1. Network 172.16.1.9. So all the interface under the RR3 need to be advertised between ASPR3, RR4, and the PE3. Okay, and next step, interface gate 001, OSPF cost 1000. Interface gate 00, OSPF cost 50. Interface gate 002, OSPF cost 1500. Yeah, this is on the configuration on the RR number 3, RR3. So far, okay? Up to this, any questions? So this one is pretty straightforward. As long as you did not miss any interface that not advertising, you should able to perform this OSPF question. Okay, so I will continue with the R4. Okay, display IP interface brief. Same thing, this need to have a 3 physical, 1 loopback interface. So first I define the router ID 172.16.1.10. All right, then followed by the configuration here, as in hold on, some question asked. Why that is not .2? Okay, so someone asked about just now, I think it's Jackson. They asked about why the OSPF 10.1.79.2.0.0.0.0, why not is 0.0.0.2. So over here, this is a wildcard. This is a wildcard is correct. But why there is not .2? It because of you can put .2 is okay. But right now, because of on my site in OSPF, I just advertising a exact address. I because it's only point to point. I just to tell you that this is my address need to be advertised into the OSPF. You just advertise what you know into the OSPF. I not to advertise the entire segment. You can advertise segment, but from your site it's only a host address. It's a point to point addresses. So we do not need to advertise as a /24. So it's nothing wrong over here. You can use as a 24 as well, but you're getting the same result. So to make it more precise, I will doing this way, 10.1.79.2. Let's say you want to using 0.0.0.2. I think that 0.0.2 they will going to do this. You need to use this method. Instead of using that, you can using a network 10.1.79.0.0.0.3. That is the things that you can be performed. Instead of 2, you can using a 3 because you are using a /30. /30 reverse subnet mask will be 3. You cannot use 2. The 2 is only used into the ACL. ACL you can perform using a 2 or 1 and so on. But into the OSPF, they must match exact your subnet mask, reverse of your subnet mask. Okay, so you can using this way or network 10.179.2.0.0.0.0. This is to tell that this is my exact addresses. Instead of you going to advertise the segment, I'm going to advertise just a host address. So two-way also possible. You can using a .3 or 0. Because all the address in between is using, when you refer back to this, when refer to IPv4, it's all /30. When this /30 convert back into the subnet mask, it's a 255.255.255.252. So the reverse subnet mask will be 0.0.0.3. Okay, .3, not .2. So it can be using both. You can using .3 or you can using the .2, .0.0. The best practice will be 0.0. Okay, you just advertise what you have exactly. Let's say internal you have 10.1.1.0, 10.1.1.2. Let's say you have this address. In your environment, let's say you have this 10.0.0, you have 10.0.1.0, you have 10.0.2.0, you have 10.0.3.0. It's all within your routers. Then you can doing this advertisement. Network 10.0.0.0.22. It means that it's 0.0.0.0. 22 is about 22. It'll be 7. Okay. So you can use it 0.0.0.7. Something like this. This is a 2.5.3, sorry. 253. 3.255. Okay, this is what you're advertising. Let's say you want to advertise this 4 network, you can using 1. But let's say it's just a point to point, your direct interface, then you can using this 10.0.0.1.0.0.0, network 10.0.1.1.0.0.0, network 10.0.2.1.0.0.0, network 10.0.3.1.0.0.0. You can do it in this way, or the way just I mentioned, you can using network 0.0.0.0.0.0, 3.255. This is what you can perform. But the better way to prevent you advertise the wrong segment, using the exact will be the best practice. Okay. So that what I was going to suggest. Okay. Let me come back to this OSPF. R3 done. Then I go for RR4. I changed router ID already, and the next one I'm going to be changing from here is go to OSPF 1, area 0, network. I have 10.191.2, 10.181.2, 10.1.102.1, 172.16.1.10. Okay, that is a for interface advertising, and followed by interface gate 000, OSPF cost 00 is 50, interface gate 001, OSPF cost 1000, interface gate 002, OSPF cost is 1500. Okay, that is on the RR4. Okay, RR4 configurations. Let me copy this. Okay, this is on the router number 4. It's okay up to this point. Okay, then the next one is on the PE3. PE3, they have 2 physical, 1 logicals. Okay, we need to advertise gate 002 and gate 000. Okay, these 2 interface. So it'll be 10.1.112.1 and 10.1.119.2. These are the 2 interface. The sub interface, you can, this is on not over here, sir. This is not been done yet, and the loopback interface. Okay, so I'm going to define the routers ID 172.16.1.11. Okay, OSPF 1, routers, network, area 0, network 10.1.112.1, 10.1.119.2, network 172.16.1.11. Okay, that is addresses need to be advertising, and interface. Interface gate 000, OSPF cost 20, interface gate 002, OSPF cost 1005. Okay, that is for the PE3. Okay, for the PE3. All right, then continue with the last routers here. Okay, last routers is on the PE4. Okay, PE4. Display IP interface brief. So interface 4, we have gate 00 and gate 002. Okay, 10.1.112.2 and also 10.1.102.2. So that is the two things that we're defining. Okay, that's two things we're defining. All right, so I'm going to configure the router ID 172.16.1.2 first. Okay, and followed by defining the addresses. Ospf 1, area 0, network 10.1.112.2, 10.1.102.2, 172.16.1.2. Yeah, that is need to be done. And on the interface, gate 000, OSPF cost 20, interface gate 002, OSPF cost 1005. All right. So on the PE3 just now, I did not copy this into it. Okay, and PE4. Oh, shit. Okay. Click the wrong button. All right, this is on the mock on the PE4, the OSPF configuration. Is it okay so far? Is it all right up to the OSPF up to this point? So how are we going to verify our OSPF configuration? Let's go back to the ASPR3. ASPR3 display IP route protocol OSPF. So make sure you can see .2, .8, .9, .10, .11. All the different 5 routers on the ASPR4, RR3, RR4, PE3, and PE4. So make sure you grab all this information, means that your OSPF is running 5, and also the different cost value from here. Okay? So far, okay, for the Ospf, you're able to up to this point. So can I proceed to the next one on the ISIS? Okay, let me minimize and have a look. So ISIS over here, there's a bit more configuration, but it's not too difficult. It's not too difficult. In AS100, ISIS protocol is enabled on the loopback 0 and the interconnected interface. The IS level for each of IS is under level 2. Get changed level 2. PE1, PE2, RR1, RR2 belong to the area 49001. ASBR1, ASBR2 belong to 49002. The system ID of the device is converted from the loopback 0 addresses. Examples, the loopback address is 172.16.1.1 and the loopback address become the 170.116.00100 after being filled with the 0. The PE system ID with 49001.172.160.0.1001.001.00. And the cost value of each of the link is configured as shown into the figure 2. So this is also a pretty basic on the ISIS configuration. So from now, I will just give you another 15 minutes to try it out on the ISIS configuration before I give you the solution on this. Just test it out on the ISIS, okay, on the AS100. Okay, under AS100, that is the way. So ASBR1, ASBR2 is belong to 49002. PE1 up to RR2 is belong to the 49001. So they're split to two different areas. And the path numbers need to be followed exact the same that apply from here. So you just have to design all the cost numbers. Okay, that's how we did on the cost from the Ospf. Okay, so I want you to do it from your side first before I show the answers. Okay, on this, on the 2.3 ISIS. Is that okay? So I would like you to do it from your part. So right now, I will just write down the times. 11:40, 11:55. Okay, so 15 minutes. Try to do it on the ISIS. Is okay so far up to this point? On the ISIS configuration, is still doing. Another 5 more minutes, I'm going to show you the answer on this ISIS configuration. So this one actually, the question is very clear that show that what we could, what we should do. Okay, just doing step by step. Okay, so now I will showing you that how you perform on the ISIS question. So for this ISIS question, it's on the AS100. Then this is what we mentioned just now. PE1, PE2, RR1, RR2 belong to 49001. ASBR1, ASBR2 belong to 49002. So this one, make sure that you are properly defined. So I'm going to show you the configuration start from the PE1. Okay, PE1. It's better that for me to do it based on the diagrams. Okay, based on the diagrams. Okay, I will do it on the PE1, PE2, RR1, RR2, ASBR1, ASBR2. Do it one by one from PE1 first. All right. So from here, I will display IP interface brief. So under display IP interface brief from PE1 here, I will know that which interface is into the ISIS. I will have a port 0 and also port 2. Yeah, port 0 and port 2, followed by the loopback. Loopback 0 will be my network entity as well. So this is how I define from PE1. ISIS 1. IS level. Just now you said that have to be level 2. Okay, has to be level 2. And you have to do this cost out white. Okay, so because of the cost out they're using, the cost is 3,000. Okay, the narrow cost out is only from 1 to 63. That's the maximum. So let's say I want to set 3,000, we have to use the cost out white and followed by network entity 49001. So from here, I define my loopback as my entity IDs 1720, 1600, okay, 1720, 1600, 100.002. Okay, this is my network entity 1720.1600.1001.00. After that, I go to the interface gate 0, 00, ISIS enables 1 and ISIS cost 20. Interface gate 002, ISIS enables 1, ISIS cost 3,000. Okay, that is what need to be defined on this two interface. So this is on the ISIS configuration. If not too difficult here, so I will just copy this into the notepad. 2.3 ISIS. Okay, and from here, don't forget we also need to do the router IDs 172.16.1.1. Okay, configure router ID as well. Okay, always define the router ID first because on the question 2.1, they already asked us to configure all the routers with the router ID same as your loopback 0. Yeah, that need to be done. Is okay? Done on the PE1. So just double check whether you did it the same as mine or not. Okay, then I go for a PE2. So from PE2, first display IP interface brief. That's the address that I have. 10.1.12.2, 10.1.24.1, and 1.16.1.20. So that is the interface 00 and 002, as well as a loopback 0. Okay, that is what I'm going to perform here on the PE2. Sorry. All right, I define first router ID 172.16.1.20, ISIS 1, then followed by IS level 2, cost start white network entity 49001. This 172.16.00.1020.00. Okay, this is my network entity. So every single octet, just make it as a 3-digit. Add a 0 in front. Okay, add a 0 in front. Done. Then after that, I need to go to the interface, gate 000, gate 000, and say that this is ISIS enable 1, and followed by ISIS cost 20. Interface gate 002, ISIS enable 1, ISIS cost 3000. Let's say it did not do the cost down wide, you should not able to enter the cost up to 3000. Only when it's a wide cost down, they can support up to 3000. Okay, so that is on the PE2. So far okay. Then I follow by doing the RR1. Okay, doing on the RR1. So under the RR1, actually it be similar, just that from here you need to have a 3 interface. Okay, 3 physical and also a word loopback. Oh, sorry, just now I did not advertise the loopback. My mistake. So let me go to PE1 first. Interface loopback 0, ISIS enables. So I forgot to enable my loopback. Okay, I start on RR1. Okay, RR1 first interface, right, display IP interface brief. So all these interface need to enable ISIS. So first routers ID 172.16.1.3, ISIS 1, IS levels level 2, cost start white network entity 49.001.1600.1003.00. Okay, this is how we converted. And interface gate 000, ISIS enable 1, ISIS cost as a 50. Interface gate 001, ISIS enable 1, ISIS cost 1005. Interface gate 002, ISIS enable 1, and ISIS cost is 3000. Interface loopback 0, ISIS enables. Okay, that is on the configuration on the R1. Is it okay up to this point? All right. Is that okay? I do an RR2. Okay. Display IP interface brief. So for this, same things. All the interface must be in the ISIS. Okay. So first, router ID 172.16.1.4. ISIS 1, IS level 2. Cost down, white. Network entity 49.0.172.1600.1004.00. Interface gate 000, ISIS enable 1. So for gate 000 is on the cost of 50. Interface gate 001, ISIS enable 1. ISIS cost 1500. Interface gate 002, ISIS enable 1. ISIS cost 3000. Interface loopback 0, ISIS enable 1. Okay, that is everything you need to be done on the route refactor number 2. Okay, that is on the 49001 areas. So right now we configure ASBR1, ASBR2 as belong to the area 49002. Okay, I configure on the ASBR1. Display IP interface brief. So we have the interface of gate 000 and gate 001, 56 and 35, and your loopback 0. These are the three things that we are focusing. 56 between the RR1, ASBR1, ASBR2. 35.2 is between the RR1 to the ASBR1. All right, so routers ID 172.16.1.5. ISIS 1. IS level 2, cost stout, white. network entity 49.002.172.16,000.1005.00. Okay. Interface gate 000 ISIS enable 1. ISIS cost is 100. Interface gate 001 ISIS enable 1. ISIS cost 1,500. Interface loopback 0. ISIS enable 1. Okay, that's configuration on the ASPR 1. Okay, so I'll copy this into the notepad. So this is the difference that is on the belong to 49002. Okay, and the last routers is on the ASPR2. Under ASPR2 also have two interfaces. Okay. What happened to my ASPR2? Okay, it's a bit slow. Okay, displays IP interface brief. So you have a gate 000, gate 001, and the loopback interface. Okay, router ID 172.16.1.6. All right, then we can start to define the ISIS 1. IS levels level 2. Okay, cost out wide. Network entity 49.002.1600.1006.00. Interface gate 000, ISIS enable 1. ISIS cost 100. Interface gate 001, ISIS enable 1. ISIS cost 1,500. Interface loopback 0. ISIS enable 1. Yeah, that is on the configuration on the ASPR2. So let me copy this. All right, so that is on configuration on the ISIS. So from here, we need to make sure that verifying that ISIS has been defined properly. So let's say on the PE1, after it configured done, you should able to check display ISIS routing. ISIS route, you should know how to go to 1.5, 1.4, 1.3, 1.1, and 1.6, and 1.20. Okay, myself is a 1.1. So that's all your ISIS route has been learned. And also you see that they are learned from different areas, but it doesn't matter because every single one are using the level 2. Level 2 actually they have no differences. It's just seeing that they have level 2 database. They did not tell where you come from. You just have a database directly showing from here. Is that okay? So far, all right. Up to this on the ISIS, did you able to form your ISIS? Make sure the ASBR also can see your ISIS information. Display ISIS route. So you should learn everything that come from 1.1, 1.20, 3, 4, 5, and 6. 6 is myself. So you can see the 6th device has been shown over here. So far, all right. Up to this on the ISIS question. So at the same time, I will just save this information and send you an updated one. So at least that up to the ISIS has been done from here. Is all right? So I already sent into the group. Just double check. Okay. So let's say you did not able to follow, you just double check with the text. The text file that I share, it can be just copy paste into the configuration to make it work. All right. So for the next thing that we look into this, you look into the session number 3. Yeah, session number 3 is on the Mpls Vpn. Mpls Vpn over here, they're going to have a lot of steps need to be done. From step number 1 up to step number 10, make sure that can ping to the destination of 10.3.3.3.3 is succeed. So on the step number 1 is to creating your VPN instance. PE1, PE2, PE3, PE4. Set the route distinguisher to 100:1. Export route target to 100:1. As shown into the figure, eBGP peer relationship is formed to the CE and the PE. So check on the figure number 3. Okay, so that is on the information that you need to be aware. You have a eBGP, eBGP, eBGP connection. And for RR1, RR2, they have a route reflectors. RR3, RR4 is a route reflectors. So you need to know the detail from here. Okay, so CE1, CE2 advertise a network segment of 10.3.1.0 and CE3 advertise a 10.3.3.0. And in the AS-BGP VPN option B should be deployed between AS100 and 200. So you perform on the option B. Okay, option B, still remember how to perform on the option B? So that is what we need to do over here. And in the AS100 R1, R2 VPN 4 route reflectors, configure the same cluster ID among them together and PE1 and PE3 as a reflect client. As same as the R3 and R4, cluster ID is 1.9 and the PE3, PE4 as a reflect client. Local preference attribute BGP is adjusted so that PE1, RR1, ASBR1, ASBR3, RR3, PE3 is preferentially selected for bidirectional traffic. Okay, both direction. They need to prefer using this way, going to the top way. PE1, RR1, ASBR1, ASBR3, RR3, and PE3. And the MED value for the route received by the CE3 from the PE4 is 200. Okay, that is what we need to define. Okay, for this is on the Mpls VPN question. So this one is a bit long. It will take some time for you to really go in through this. Okay, so you need to do it slowly, carefully, what the question is being asked. Okay, so after this, the next one is just a IPv6 and also the OSPF v6 and BGP v6. Okay, the question over here on this mock it be not too difficult. Okay, so right now we are going to perform this Mpls VPN, but I think that right now is almost to our lunchtime. So lunchtime, after lunchtime, I will give you about half an hour to do this. Maybe let's say you want to do it now, you can do it now. Let's say if not, after lunchtime, you can continue on this Mpls VPN lab. Okay, so later after lunch, I will going to give you ideas what's the question they are provided and what we need to be followed, which step by step need to be done. Okay, and also at the meantime, I also will save my configuration first. Save the configuration at least that you can start direct based on the topology that I go up to when define the Mpls VPN. Is it okay? This Mpls VPN is not only that, you also need to configure a BGP protocol as well. Like the eBGP, the iBGP, you need to be done before you perform on the option B. So you just have to recall back what I mentioned to you. Under the option B, what are the procedures? Like we need to do the basic IGP, okay? Basic MPLS. Then for the MP, iBGP, or iBGP need to be created first, and so on. So they need to be done first. So from your from that, you do it from your side. Okay. So later I'm going through this. Okay. But after lunchtime, I still give you some time for you to complete this. So I try to not occupy your lunchtime. So after the lunch come back, I will give you some time to go through this on the lab on the option, the number 3, okay, Mpls Vpn. This one is considered is the tough part into this mock lab. So that is where they're focusing to. You can see that on the ISIS or Ospf, it's pretty simple, okay? There's no difficulty at all, okay? And you need to know that inside the MPLS, in the AS MPLS BGP VPN option B, what are the way they're using? Still remember? So like option A is a VRF to VRF. MPLS VPN for the option B is the ASBR to ASBR is from the MP eBGP. And for option C is between RR to RR or the PE to PE. Okay, so you need to know the differences between the 3 different options, A, B, and C. So which one we should use into the different option. Is it okay? So let's say now you have another few more minutes. You can start to do, then you can go for your lunch and come back around 1:30. We're going to go through this again. After another 30 minutes, I'm going to go through the answer for you together with all of you under the MPLS VPN. Is it okay? So let's take a break right now. Then come back. We can start on this MPLS VPN lab. This one, it might take more time compared to the ISIS and the OSPF. Okay? So we take a break right now. Take our lunch break. So for this one, I will just write it down over here. It's from 13:30 go up to 14. Is it enough? 30 minutes? I think it's around there. Or 30 to 40 minutes from this. 30 minutes to 45 minutes. Okay. But I will just fix to 30 minutes first. Let's say it's not sufficient. I'm going to give you more time on that. All right. But now let's go for our lunch first from 12:30 to 1:30 and come back. We continue with this lab. Is it okay? Do you want me to save the config file for you or the text file is good enough already? Is it okay? Like this? Do we need to get the information on the config file? Okay, text file is good enough, so I will not. Okay, so I do not save my config file at this moment. So let's say you have anything, then you just let me know again. All right, let's go for lunch.